we're going to first take a look at these things called sample spaces. All right, so since you haven't had very much information on this, we're going to write some formal definitions here. So sample space or sample spaces. Okay, definition: it's the set of all possible outcomes of an experiment. So a lot of times you're going to have to list the sample space. Sometimes the sample space is going to be really, really small and it's going to be really, really obvious. All right, so if I asked you what the sample space was when you roll a dice, the sample space would be what could come up when you roll a dice. A 1, a 2, a 3, 4, 5, 6. Okay, so that one's a simple one. We can just do that in our head. All right, and there's going to be several of them where the sample spaces are just common sense, you know, like sample space from drawing like a card out of a deck of cards. How many cards are in a deck? There's 52. All right, so technically we could list them all. All right, you've got all 4 suits, the red and black. Okay, so that's a sample space. That's what a sample space is. All right, every member of that set is called an outcome. All right, so each member of, and usually they do a capital S to indicate sample space. All right, so each member of the sample space is called an outcome. And when I ask the question, if I roll a dice, you know, what's the possibility of coming up? Those are the outcomes. All right, now these sample spaces can either be finite or infinite. All right, so for the most part, we're just going to deal with the finite ones, the ones that have a set number. Like when you roll a dice, there's only 6. That's finite. There's 6, and that's it. You're going to use set notation if you're going to have to write these. All right, let's say it says list the sample space. I'm just going to use capital S. All right, list the sample space. And I've already done the dice. Okay, so let's do, what if I said list the sample space for tossing 2 coins? All right, now, the reason I picked this one is because some of these you are going to be able to just do in your head. When you toss 1 coin, what comes up? Either a heads or a tails. All right, now stop and think about, I'm going to toss the first coin, then I'm going to toss the second coin. So my outcomes, what could happen? I need to do it as a set, so I'm going to do some set brackets. All right, technically, I could toss the first coin and get tails, and I could do the second one and get tails. So I could get tails, tails. That's 1. All right, I could toss the first one and then toss the second one and get heads and heads. Okay, so that's another one. I could get a tail on the first one and a head on the second one. Or when I toss the first one, I could get a head or a tail. Any other way for the different things to come up? No. See, so sometimes they're going to be that simple, and you can just, because there's not very many possibilities. Okay, so it's going to be a relatively small sample space. Okay, now, if it gets more complicated, if there are more things to choose from, because I could say we're going to toss a coin, we're going to roll a dice, we're going to pick a card out of a deck of cards. That would be a lot of different choices because there's 52 in a deck. So, you know, tails and then, you know, 1 of the 6 and then 1 of the 52. It's going to be huge. All right. So there's an organized way to make these sample spaces. All right. And it's called a tree diagram. Have we ever heard of a tree diagram? So I got a couple people who just said yes. All right. Tree diagram. Let's just say produces a sample space. All right, now, since obviously this could get completely out of hand really, really quick. I'm going to do a relatively small one just so we understand the concept. Okay, so let's suppose, let's not do the one with cards because that would be like virtually impossible. Let's just go back to a coin and let's say we're tossing 3 coins. Okay, so I've got 3 actions that are going to happen. I'm going to toss a coin once, I'm going to toss a second coin, I'm going to toss a third coin. All right, so I'm going to set up columns for each one of those. And I'm going to space them out relatively far so I've got room to draw this diagram. All right, so this would be my first coin that's being tossed. This is going to be my second coin that's being tossed. This is going to be my third coin that's being tossed. And then I'm going to be able to list my outcomes in a 4th column over there. Some of you are going to be able to draw this really good. Some of you are not going to be able to draw this very good. Okay, so when I toss the first coin, we know we either get heads or tails, right? So I'm going to put heads or tails here, and I'm going to space them out because this is going to create a tree, and it's going to branch and get bigger as we go to the right. So I'm going to put my head all the way down here, and my tails maybe down to here. Okay, now, when I toss my second coin, I still have heads or tails, right? So off of this first coin, I have 2 choices. And I'm going to try to line this up underneath here. Heads, tails. After this one, again, that second coin, I have 2 choices. I'm going to try to make my little diamonds here. Try to make that all in that column. After each one of these, regardless if it was a heads, if it was tails, if it was heads, if it was tails, my third coin is going to have heads or tails. So I'm going to have a branch off of this one. I'm going to have a branch off this one. A branch off this one, where our branches start to hit each other. So this is where some of you are going to be better drawers than others. Got heads, got tails. Now, do you see why we would not necessarily want to do this if it was toss a coin, roll a dice, and then pick a card? Because if it was pick a card out of a deck, I would have to have 52 off of each one of these. Not very practical. Okay, now, can I go through this chart and follow every path? So I could go all across the top and get just heads, heads, heads. Following almost across the top, but then coming down here, heads, heads, tails. Heads on the start, tails on the next one, going up. Heads, tails, heads. Heads, tails, tails. So what this does is it creates a systematic way, this would be tails, then heads, of you listing in an organized fashion all the outcomes. Let's see, tail, head, tail. Tail, tail, head. Tail, tail, tail. And with this one being short, could you possibly have went through logically and just stopped and thought about it and got every one of your possibilities? Yes, you could. All right, now, if it says how many are there, well, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8. There's 8 outcomes. If they ask you what are the outcomes, you would have to list all of them in set brackets with commas in between them. Okay, so there's a difference between how many are there and what are the outcomes. What is that set of outcomes? All right, so far so good? All right, now we need to be able to come up with how many there is for the deck of cards and the coin and the thing. We've got to have a method. So yes, there is a shortcut. All right, it is called the fundamental counting principle. All right, fundamental counting principle basically says all I got to do is take all the different possible outcomes from each event and multiply them up. Take all the different possible outcomes for all of the different events and multiply them out. So let's go back to this diagram. I had 2 outcomes for this first one, which was a heads or tails. I had 2 outcomes, heads or tails, for this one. I had 2 outcomes for this one. 2 times 2 times 2 equals 8. Okay, so you can get the number of outcomes by just multiplying. Now, this one was all 2, 2, 2. All right, let's go back and let's do one that we just said. What did I say my example was? It was a coin was the first one, and then a dice, and then a deck of cards, drawing from a deck of cards. Okay, so how many on the coin? How many outcomes? 2. How many on the dice? 6. How many decks of cards? How many cards are there? 52. All right, so 12 times 52 is 624. So there are 624 outcomes if I flip a coin, roll a dice, and pick a card. And no, we would not. I would never ever ask you to list 624 outcomes. All right, something smaller. All right, definitely you should be able to list them. But now this would also work. We're going to assume that you're colorblind, you have no fashion sense, and you don't really care what you look like after you get dressed. But in your clothes, in your closet, all right, let's take a guy, for instance, because they're less likely to be concerned about what they are wearing, right? So let's say they have 3 different ties in their closet. Let's suppose they have 4 different pairs of pants, and they've got 2 shirts, very limited. How many different possible outcomes could they dress in? Well, all you got to do, 3 times 4 times 2, 24. So they have 24 different outfits that they could choose from. And we are assuming that, you know, no fashion, just whatever. They're just reaching in, picking one of everything. Okay? So it's a pretty simple concept.